Yeah, so a very good morning to all of you. So today we'll be starting about. Am I audible to all of you?
Yes, sir.
Ashad, I can't hear you because
Yes,
Yes,
sir.
sir,
You
you are.
are audible, sir.
just a minute. Yeah, my voice is audible to all of you.
Yes, sir.
Okay. Thank you. So today we'll be starting about the relative address that has been already discussed in the jump operations. So today we'll see that how the jump operations there we have seen that some relative address is there. So the thing is, what is the advantage of this particular relative address? Okay. Now let us see. Just see in the copy that in the 8085, suppose there is a program written from 8000H to suppose 8100H. Okay. So suppose this program has been cut. Okay. So you people know about this copy paste and cut paste. If we do cut paste, then the source one will not be there. Okay. Whether whenever if the program or anything can be copy paste, then this will be available in the, just a minute. Yeah, so if we do a copy paste, then the source material that will be unchanged. But if we do cut paste, then source will not be there. Okay. Now suppose inside this 8000H to 8000H, I am writing, just a minute, H memory location, and it is going on, and some program is written, and suppose 80A0H, there is a jump program. Okay. And some address is written as suppose 80B0. Okay. H. So some memory location will be there and 80B0H will be there. Okay. So some program is again written. Okay. And after that return, that means in the next memory location, that is 80A3H. Okay. And this program will go up to 8100H, and this is the end of the program. Okay. Now you tell me that whether this particular program has been cut from this memory location to 9000H memory location. Okay. So the program will run up to 9100H. Okay. Now tell me that if the program has been cut from 8000H to 9000H, will the program run? Will the program run or not?
No, sir.
Why?
Because the jump instruction has locate 80B0H.
Yes. So that is very good. That is 80B0H. So if we cut from this location to this location, the inside of the program, the jump operation will still denoting this 80B0H. But as the program is not there, this program is available here. So 80B0H location will not hold this particular program, right? So this program will give an error, right? So this program will not run. Clear? So to avoid this, so in the 8085 microprocessor, this was the disadvantage of this particular microprocessor. So to overcome this kind of disadvantages in 8085 microprocessor, 8051 in 8051 microcontrollers, there are the concept of relative address came. Okay, so what is the relative address? So look into the PPT. There is relative address is nothing but the difference between two 8-bit numbers. Sorry, two 16-bit numbers. Now why 16-bit? Because it is the difference between two addresses, okay, from source to destination. Okay, now this there are other addresses too, address ranges. This is short address and long address. Okay, so short address and long address is a bit easier one, so let us complete this first. So short address, just see in the diagram in the PPT that there are two 8 bit. Okay, so these two 8 bits, that means the lower 8 bit, every 8 bit will be calculated. Okay, clear? And the upper only 3 bits will be calculated. Okay, these 5 bits will not be counted by default by the manufacturer. That has been designed as these the upper byte, the lower 5 bits are fixed, no change. Clear or not?
Yes, sir.
Okay, so so if we go through this, just see that how many bits are involving to generate the address. How many bits? There are 8 bits and these are 3 bits. Clear or not?
Yes, sir.
So 8 plus 3, look into the copy. So 11 bits will be there to generate the address. So what will be the address range? That will be 2 to the power 11. That means we can write 2 to the power 10 into 2, that is 1k into 2, that is 2k. So in this case you can see the short address, this is address generated by 11-bit address and maximum range is 2 kilobytes. Okay, understood? Why 2 kilobytes? And the long address, that is will be coming, no, here is not there. So in the long address, unlike the short address thing, the total every bits will be calculated, all the bits. There are no bits that will be set by the manufacturer previously. Okay, so here unlike this absolute one, the short address, this will not be, this will be considered. Okay, so whatever the value will be there in the bits, that will be calculated. So to generate the address range, 8 plus 8, so total 16 bits will be needed. So 16 bits means 2 to the power 16, that means 2 to the power 10 into 2 to the power 6. Okay, that is 1k into 64, that is 64 kilobytes. Clear? So the long address will count 64 kilobytes. Okay, because this is generated by the 16-bit address. Okay, any questions? Okay, so let us proceed. Now the concept of the relative address. Okay, now how to calculate the jump address? Okay, what is the relative address? Now we are coming. So before discussing this relative address, we'll just look into the program, okay, that is shared in the PPT. Look, here the program counter, this org 00000h, that means this is the assembler directive. Whenever we are writing a program, we will use this org 00000h because this particular directive indicates that the program will be starting from this memory location, this 0000h memory location. Clear? Now 0000h memory location, in the in other words, we can also say that this org 0000h, after that the content of the program counter will be set to 0000h. Okay, so that the programming starting from here. Clear? So in the 0000h, that is nothing but the move r0 comma hash 0. That means the r0 register in the bank 0, as because there are no bank is selected by default, bank 0 is selected. So in the bank 0, r0 register will be loaded by the immediate data 00h. Okay, and this is the 2-byte instruction as one mnemonics, one byte, and one 8-bit number, that is 00h. Here 0 means 0 decimal, 0 decimal and 0 hexadecimal, that are same. So if we do not put any h after the number, then the microcontroller will understand this as a decimal number. Clear? So this program, I mean, just a minute. Yeah, so this will be located 0002, that means this is 2-byte instruction, so 0000 plus 2. Okay, because this is a 2-byte instruction. Okay, now here again in the next instruction, this is also a 2-byte instruction, so it will be plus 2. So the next memory location that will be indicated by the program counter, that will be 0004. Now comes the JZ next. Okay, now where is next? Next is, we can see this location. Okay, so the memory location is 0009. Okay, now we will see that JZ next, why this is written. Now whenever executing this JZ next, the content of the program counter will be what? Again I am repeating, whenever the this line, this JZ next, this is executed, then what will be the content of the program counter? Tanisha, tell me. Tanisha Kumari, you are not there. Tanisha Kumari, you are not there. Okay, so I am removing you. Shreya Kumari?
So program counter will increase by 1.
No. Avinash Shukla?
Yes, sir.
So, what will be the content of the program counter?
Sir, it's jump to next or next, sir. 9 number.
What is my question? Just repeat. What is my question?
Sir, JZ next where सर वो जंप कहाँ करेगा वो सर आप पूछ रहे थे.
Sir, it will be 04.
No.
Jump next 009, sir.
No.
009.
No. I'm again repeating my
Sir,
question.
002.
Again repeating my question, then you give your answer. That what will be the content of the program counter while executing this particular instruction JZ next? Okay. Now you can answer.
So can you please repeat once more?
Just write in your copy whatever I am asking, write in your copy so that you can go over it again and again. That when executing the instruction JZ next, then what will be the content of program counter? Jairam Mardi. Jairam Mardi.
Sir, it will be
Yeah, Aditya, tell me.
add A to the immediate data 77H.
No, wrong. This is not correct. Pradeep Singh. Pradeep Singh, you are not there. Pradeep Singh is not there, so I am removing you. Jyotsna Nag.
Yes, sir.
What was my question, Jyotsna? Jyotsna Nag, what is my question?
Sir, when you have asked that when we will execute the ZZ, then where it will go?
No, I didn't ask you this. What I have asked?
So when we will execute the J next, then what will be the value in the program counter? What will be the
Yes, that was my question. Neha Kumari. Neha Kumari,
Yes, sir.
give the answer. What was my question?
When we will execute JZ next, and what will be the next?
What will be the next? Next what?
Next.
Shalini Priya.
Yes, sir.
What was my question?
सर प्रोग्राम काउंटर का वैल्यू क्या होगा जब जे जेड नेक्स्ट एग्जीक्यूट होगा तो
What is your answer?
Zero six.
तो अभी तक क्यों रिस्पॉन्स नहीं कर रहे थे? As because the program counter will hold the value of next instruction to be executed, the address of the next instruction to be executed, this value will be stored into the program counter. So when JZ next is executed, then immediate next instruction to be executed is 0006. So this 0006 will be the content of the program counter. Okay. Now from 0006, just look into this, look into the program. From 0006, this next is here, that is in 0009. So 6 to 7, how many counts? 6 to 7, how many counts?
1,
7 to 8
1,
and 8 to 9.
1,
So total is 3.
3.
Okay. So that here in the program, that will be written as JZ next. So here in the output section, you can see this 03 is located. Okay, because of this one. Clear? Or any questions? Any questions? Understood or not? Now similarly, just you can see this JNC over, this JNC over in the next while executing this JNC over, the content of the program counter will be 000D. Okay, the next instruction to be executed. So here the over is here in the 0012 memory location. Clear? So D to E, how many counts?
1,
2, 3,
1,
4, 5.
4,
Okay.
5, and 6.
Okay, so that here 05 is written. Clear? Clear or not?
Yes, sir. Yes, sir. Yes.
Okay, so again just another loop is there. You can see JNC again. Okay, but again is here. Okay, now I'm erasing everything because otherwise it will create some. Now this will jump in this location. Clear or not? So what is the difference between this JZ and JNC jump and this JNC again jump? Look, in JZ next, the jump was in from this direction to this direction. Okay, that is JNC over also from this direction to this direction. Okay, that means this to this means low address, lower order to low to high. Clear? The address is low to high 0002 से 000B ज़्यादा है. So this is the flow of the program, direction of the flow of the program. So from low to high, every program is executing. So from low to high, this is called the forward jump. Okay, when the program is flowing from the lower address range to higher address range, then what is there? This is called the forward jump. Okay, similarly unlikely this JNC again, that will go this way. Okay, that is from high to low. Okay, so this is called backward jump. Okay, backward jump. So there are two jumps are available. that are forward jump and backward jump. So JZ next and JNC over, this was the example of the forward jump, where the source address is lower than the destination address. But in case of JNC again, the destination address is lower than the source address. Clear? Because obviously 0013 is greater than 00, actually not, 0015 will be there. 0015 is greater than 0007. Okay. Now how to calculate? How to calculate this? Just calculate the difference and calculate the 2's complement. Okay. Now how to calculate the 2's complement? Anyone can say? How to calculate the 2's complement?
Sir, first it will be converted into first complement and then it will be incremented by 1.
So I can give you a short one. I mean, is a shortcut. Suppose 0 0 1 1 1 0 0 0. Okay. So what will be the 2's complement of this particular number? Calculate and tell me.
Zero zero one 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 001.
Okay, taken. Now next, anyone? Jaira Mardi. Jaira Mardi. Jaira Mardi, you are there or not? If you are there, please unmute yourself. Okay, so I am removing you as you are not present in the class. Anyone other than Aditya? Yeah, Vishaka, tell me. You are not audible, Vishaka.
Sir, 11001000.
Okay. So, whatever the technique you have adopted, just I'm telling, just write in your copy. Okay. So this is the don't you don't need to convert it to its equivalent. I mean, one's complement and add 1 with it. Just remember, up to last non-zero term unchanged. I'm repeating once again. To find out the 2's complement of any binary number, up to last non-zero term unchanged, then 0 will be 1 and 1 will be 0. Okay. Again, third time I am repeating, up to last non-zero term unchanged, zeros, after that zeros will be 1, 1 will be 0. So here, what is the up to last non-zero term? That is 1. So this will be unchanged. Okay, from this way, then 1 will be 0 and 0 will be 1. So this is the 2's complement. Is this clear? This is the
Yes,
shortest.
sir.
this is the shortest way to find out any binary number 2's complement. So here also in the particular this particular program, from 1 5 and 0 7, that is the negative direction. One is forward. Whenever the direction is forward, then no problem, that is the whatever the difference is you can write, okay. But whenever the content is, I mean, whenever the jump is backward, then you need to do the 2's complement, okay, clear? Because this negative sign indicates that this particular jump is backward. Clear? Any questions? Now relative address is understood or not?
Sir, can you please repeat the last part?
Which one?
Backward jump.
Backward jump is nothing but, you can see this 8 suppose just a minute. Yeah, so JNC again, so here it is jumping from this one to this one, okay. So whenever the JNC again instruction is executing, then the content of the program counter is 0015 and it will jump to 0007. So whenever calculating forward jump, we are just calculating destination minus source, okay. The difference is how much the difference is, okay. So here also we will do the difference between the destination and source, but here the destination is lower than the source, and in hexadecimal number you cannot make the machine understand that what is negative. I mean, they will the machine will understand only 0 and 1, no sign. They will understand only 0 and 1, and whenever the most significant bit in an 8-bit number, the most significant bit is 1, then the number is negative, and whenever the most significant bit is 0, then the number is positive, okay. So here this particular backward jump, you can see the destination is lower than the source one, okay. So the result will be some negative number, clear? So 2's complement,
Yes, sir.
2's complement is nothing but a negative of a number, the changed sign, clear? So just calculate the difference between these two and make the 2's complement, then you will get this F2, clear? Understood
Yes,
or not?
sir.
Okay. And similarly this whenever executing this S jump here, you can see this S jump here is in the same line, okay. Same line means the program counter value while executing this one, this will be 0017, okay, and this is 0015. So this is also a backward jump, okay, because the jump is occurring from, just a minute, there is the jump is occurring from this location to this location. This is also a backward jump. So just you can just go and calculate the difference, that is 2. You can convert it, I mean find out the 2's complement of this 2, then you will clearly find out, clear?
Yes, sir. Clear.
Okay, so I'm stopping this. Do this quickly.